Hello, good morning, good afternoon, or good evening, whenever you're watching this video. Hello, I am Bhavana Bisht and I am going to be conducting today's session. So let's get started. I hope you're able to see and hear me clearly. Yes, let's begin. Today we are going to start with a very new chapter because we have finished with carbon and carbon compounds. You can go and check it out in the recording section in the playlist. And today we are going to start with the periodic classification of elements. That is correct. Before we dive into the topic, you know what we do, right? Let's get to know more about Unacademy's plan for you and how they go. Guys, you can join Unacademy Plus. And I'm not just saying so because here it is. Live classes for all subjects, daily, weekly quizzes, doubt solving live classes, practice questions, test series, everything at your fingertips. And you know what the best part is? Like, at least me, I know to you also, you can have access to all of it just by staying in the comfort of your houses. Correct. So what you need to do, you need to select one plan which suits you the most. And you can obviously go for 9 to 12 subscription. Yes, for 4 damn years. And there you get the cost to be less than 1,000 per month, which is the cheapest and the best quality education that you're going to get out there. That's correct. But ma'am, we heard there is something called as iconic subscription also, which is there, and you heard it absolutely right. We have the iconic subscription, which offers you something extra. And what is that extra? That is a personal mentor. Yes, if you are in a situation where you don't understand things, come on, pick up your phone, call your personal mentor, and that person will be there to help you, to guide you, and lead you about. Yes. Along with live doubt solving sessions and parent connect, because I know you don't like when you're low marks. I told your parents, right? Yeah, you want it to be a secret. But let me tell you from experience, it is not good to have it a secret. And this Parent Connect helps your parents to understand you better, how you're doing academically, and that is going to be life changing, guys. So you get the amazing Parent Connect along with a study planner because I know you being in 10th standard, you open your books and you're like, what to study, how to study, when to study, time in a year. Oh my God, yes, that stress with the boards approaching. There's only one amazing formula is to plan. If you fail to plan, plan to fail. Yes. So planning is utterly important. And for that, we have the iconic subscription. These are the plans for iconic subscription. And you can go with any of that. But before you do that, if you like me, you know what to do, right? And if you like all the amazing things that we learn together, you can just use my referral code and get 10% off. That's correct. So you can use my code and get a 10% discount. That is right. Now, this one slide gives you all the information that you need to know about the upcoming batches, ongoing batches, and the best part is, if you don't understand Hindi, attend the sessions in English. That's correct. And if you don't understand either of the languages, English or Hindi, attend the language, attend the session in another language. That is easy. So no language barrier, guys. Congratulations. And let's move on. Let's put our thinking caps on and let's crack it. But let's how our brain is meditating in that beautiful slide. Let's do it. And let's begin. So today we are starting with the periodic classification of elements, and we will talk about it. We will talk about periodic classification of elements. Before that, I have a question to ask. Do you like shopping? You can answer in the comment section, or you can think to yourself, do you like shopping? Now, it's not necessary that you want to go and shop for clothes or stationaries or makeup, just shopping in general. Yeah, it could be when your mama asks you to bring dhania and pudina from the bazaar. Yeah, or anything else. So most of us do like shopping, especially now in the Diwali season. When you go out there and you see all those wonderful lights and amazing colorful streets, and it's like, oh my god, this is so beautiful, right? So we all like shopping a little bit. But would you be ever able to shop from a from a supermarket that has the arrangement something like this? Can you ever shop from this? All the things are cluttered, lying on the floor. Do you think you can ever be able to get a hold of anything that you require? And that too on time? We cannot, can we? So, but if I put you into another scenario, and that scenario being this, do you think can you shop now for all the items that you need with an amazing trolley at your hand and all the things are amazingly put on the shelves with labels, with prices, with discounts? Now I can shop a big deal. I might even buy things which I don't want. Yeah, that I know. But isn't it more easier? Yeah. So what was the difference? Why could I not buy here? I will be just stomping on things. But here, I just have this feel. Oh, I can shop this, I can shop this, I can shop this. Yes. But I would like to put you in another scenario. Just imagine this is your room. And your mama is about to enter in, let's say, 10 seconds. You know what would happen after that, right? It is not going to be good either. One of us. Flying choppers received. But just imagine if your looks like this. No mess at all. And your mama is going to enter in 5 seconds. The reaction that you're going to get is different to another level. That too because of just one small little thing. Can you guess what that is? I'll give you 10 seconds to guess. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. The only difference is organization. That is right. When the things were not organized in the supermarket, everything was just lying around and you could never find the thing that you wanted on time, or you would ever find it. Same goes to your room. If it is clean, mommy will be like, mera bacha, you are the only one who's learned from me, who keeps the room clean. Yes, organization is the key. So now imagine how many elements are known to us today. That is 118 elements, right? That's a big number. Now just imagine, I take each and every element. We are scientists. We are chemists. We take each and every element, we study. Yes. And then I'm like, you know what? Amazing material. Let's print a book for all of these 118 elements. And if you print a book, I'm damn sure there's going to be more than 500 pages. Yeah, with all the massive information that needs to be in there. Yeah, that's right. If you want the element, if you want to know about something in that particular second during your research, where you're like, oh, what is it? And will you go to a 5 100 pages book and flip through the pages. Mhm. So over here, we have the need, the necessity to organize these 118 elements. Yes, the organization of these 100 elements is our necessity. Why? Because we want everything to be available to us at a glance. Whatever I need, whenever I need, at just one glance, and I get all the information that I need. Yes. And this necessity, this organization led many people to embark on the journey of organization with the elements that we're discovering every day. Yeah. And it started in 1817 by a German chemist, Wolfgang Döbereiner, who was like, let's arrange these elements. Yes. And what did he do? He was looking at the elements. Yeah, we all do. And we're like, you know what? This and this are similar. Their properties are quite similar. And you know what I'm going to do? I'm going to group them. Why? Because they're similar, right? If you and me share the same hobbies or same color, or we would be doing the same chores in the lockdown, like cleaning the floor, washing utensils, we could be able to connect better on that personal note, right? And our group would be strong. So similar properties it is. What did he do? He took three elements each. He took three elements. He identified them as a group. And he was like, you know what? These three elements, which form one group, are my triads. That is right. He called them as triads, but to honor him, we today call them as Döbereiner's triads. That is correct. So, what is so different, unique about Döbereiner's triad? So, when he took these three elements, he wrote them, let's say A, B, and C. Yes, he arranged them in the increasing order of their atomic masses. Okay, so it was not haywire. These A, B, C were placed in their increasing atomic masses. So if this was going to be 2, this is going to be 4, and this is going to be 6. That is correct. So increasing order of atomic masses. And you know the best part? The best part? The best part was when we took, wait a second, let's change the color and put up A, B, C, 2, 4, 6. Yes. And when he took the first and the last element, yes, absolutely correct. He very nicely just went on to do a little simple math. He found out the average of the first three elements, first and the last element, and what did he discover? What did he find out? And this amazing theory, and this amazing thing is what makes Arrhenius strides to come into your textbooks. Yes. So when I say 2 plus 6, how many numbers? 2. So that goes by 2 plus 6, divide by 2. So we know bod mass and we will add first and then divide. So it is going to be what? 8 by 2? Yes. You're thinking what I'm thinking? Bod mass is not required here. So it will be 8 by 2, and when I divide 8 by 2, I get the answer as 4. And voila! Congratulations! The 4 is the atomic mass of the middle element. That is right. So this is how Döbereiner's triads came into existence. Let's have a look at one of them. So come on. You and me, let's do the math together. 6.9 plus 39. 6.9 is the atomic mass of lithium, and K stands for potassium, and the atomic mass of potassium is 39. So what do I do? Average it out? Yes, let's do it. So when I average it out, I get where? Let's do the addition here. Yes, 6.9 plus 39.0 gives you 9, 15, and 4, 45.9. So when I divide this 45.9 by 2, I get the answer as 22.95. Absolutely. So is this the atomic mass of sodium, Na? Let's find out. And you all we got the answer as 22.95. But look at the miracle. And the correct answer is 23, which is just not very far away from the answer that we got. Right? Yes. So what does it say? That yes, Döbereiner's trials were a success. Right? Yes. So the mass of the middle element is the atomic mass average of the first and the last element. And this is the beauty of Döbereiner's trials. So these are some examples of Döbereiner's triad. First, we have NPAS, then group 2 and group 3. Chlorine, bromine, iodine, one of my favorites. So you need to at least remember 2 examples of the triads. The first is the Lena K, that is lithium, sodium, and potassium. Very easy to learn also. And the second, like if you go by my favorites, that would be chlorine, bromine, and iodine. That's correct. So remember at least 2 of them because you need to write at least 1 example in your examinations. And I don't want you to be relied on only one. You should have a backup. Okay. So go for it. Learn at least 2. So let's know more about our dear Döbereiner. So Johann Wolfgang Döbereiner studied pharmacy. He was a pharmacist at Germany. He studied chemistry at Strasbourg. And you'll be like, did Döbereiner only give us triads? No. In today, you take the reactions, you just put an arrow and you directly write platinum above it. Yes, you write platinum above it. And you're so sure it is a catalyst, man. What are you talking about? Exactly. But who was the one who made the observation that platinum is a catalyst? That was Döbereiner, guys. Yes. And he also discovered the trends of similarity in the periodic table of elements that he was trying to make. So these are the contributions that Döbereiner gave us. And this successful attempt was one which inspired many, and this led to let the show begin to classification of periodic classification of elements. That's correct. Let's get going. So next, in the year 1866, we had someone called as John Newlands. He was an English scientist. Yeah. And he also arranged all the elements that were known at his time in increasing order of their atomic masses. Yes. And that is, my dear students, called as Newlands Law of Octaves. So what did he do? He started with the lowest atomic mass, that is hydrogen. And he went up to the highest known atomic mass at that time because only 56 elements were discovered during that period to thorium. That was the 56th element. Yes. And what did he find out? When he was placing them in the table, he noticed that every 8th element, that's right, 1, 2, 3, 4, 5, 6, 7, and 8. Every eighth element had the property similar to the first one. It is not necessary that this should be the one and this should be the eighth. You can also, from any point you start, from any point you start, the eighth element will give properties similar to the first one. Yeah, let's consider fourth as our one. Yes, so 1, 2, 3, 4, 5, 6, 7, 8. So whatever element will be here will have properties similar to the fourth element. That is absolutely correct. So this amazing discovery is known as the Newlands Law of Octaves. And you know why? Have you ever heard Sat Sur music? Yes. Yeah. And Newland, yeah, he was an amazing fan of music. He was interested in music. What did he do? He wrote down the seven surs that we all today know as Sa Re Ga Ma Pa Da Ni Sa. But did you pay attention? Did you pay attention to something? Sa Re Ga Ma Pa Da Ni. Seven sur. But ni khatam hone ke baad hum wapas, what do we say again? We call it as ni sa. We again move back to the first swar. Yes, don't we? We do. And that is exactly what Newland octave says, the first and the eighth. Repetition, sa, similar. Yes. So hydrogen has similar properties with fluorine, chlorine. Beryllium has similar properties with magnesium. Every eighth element, my guys, every eighth element. And in the West, when you learn not the classical music of India, but if you learn the music of the West, and the surs go like do, re, mi, fa, sol, la, ti, the seven surs. But here also, the do is repeated again. Yes. The eighth, similar to the first note. And that is how Newland Law of Octaves was inspired by music. That is correct. But again, to every good discovery and the laws and the amazing logic put behind it, there was some limitations in laws of octaves. It was found out that it was only applicable to calcium. And if you see, calcium is approximately at the middle of the periodic table that he designed. We still had so many more to go, and they did not follow the Newland Law of Octave. That is right. So this was the first limitation, that it was only the Newland Law of Octave is only applicable to calcium. Yes. During that time, 56 elements were known. How many elements were known? 56 elements were known. Yes. But Newland was like, you know what, buddy? You and I'll tell you a secret. I don't think there are going to be any more elements which are going to be discovered. He was like, yeah, 56 elements. Yeah, I had these 56 elements and they are going to be it forever. But today we have 118 elements. And what does this tell us? It tells us new and more elements were discovered. And they had no place in the Newlands Law of Octaves. That is right. Why? Because he never ever considered that new elements could be formed. Another dilemma for Newland was he adjusted two elements in the same slots, but also put some unlike elements under the same node. For example, let's see over here. Cobalt and nickel don't need to be there, but they are. And you see, hydrogen hydrogen, fluorine, chlorine, bromine. What today we know, we all know all of them. That is my favorite halogen family. But there is something. The cobalt and nickel do not come in that family. So what are they doing in that box, guys? Mhm. Rather, they show similarities with this Fe, don't you think? Mhm. But they are so away from each other. They are at two ends of the table. And that was another limitation of Newland's law of octaves. He cramped two elements together in the same box, and then they did not even have similar properties in that particular note. That's right. So you can write the example of cobalt and nickel and how that SAR note only had halogens in them, and cobalt and nickel showed similarities with the properties of ferrous, that is iron, which was under a altogether different note. That is another. So this is what we just saw. Cobalt and nickel here in the halogen party, but they should be with iron, right? They are more like buddies with him. So why this? That was another limitation of law of octaves. Iron, which resembles cobalt and nickel in properties, has been placed away from these elements. So we can conclude till calcium, all the elements were quite light. The atomic mass was not so much. So the Newlands law of octaves worked very well with only lighter elements. It worked amazingly well with lighter elements. So that is about Newland. If you have any doubts here, you can ask me in the comment section. Yes, you can reach out to me on Telegram or in the Unacademy app. You just have to download the app. You can watch lectures of any educator that you like. Mhm. And you can follow me there with the profile Bhavana Bisht, and you can message me. If you have any doubts regarding this Unacademy subscription, I'm there to guide you. Or how to even go through Unacademy, how to choose what you need. Okay. So next, we move on to an amazing man, which I am just a fan of. And that is Dmitri Ivanovich Mendeleev. That is right. He was born in the western Siberia of Russia on 8th of February 1834. That is correct. 8th of February 1834. Hmm. Why do I like him? Why? We have Mendeleev on a pedestal when we talk about periodic classification of elements. Very simple. He came from a background, yeah, which could not provide him with a very good education. Yeah. So for that, his mother to put his only son into a good institute had to do a lot of efforts. Yes. So Ivanovich Mendeleev did get into the university. And when he wrote down his investigations, whatever he found out, whatever he worked upon, if you open any novel, if you open any book, a novel or a padne wala book, okay, you will always find a dedication page. And there he wrote for his mother that she instructed with example, corrected with love, traveled with me to places, spending her last resources and strength. She knew that with the aid of science, without violence, with love but firmness, all superstitions, untruth, and errors can be removed. I just love this line. Why? Because we over here, we are like, oh, you know what? I am the biggest in house, and you are going to listen to me because I am telling you to do so. But why do you want to do that? You can just instruct with example. You can be the first one to carry it out. If you want to correct someone, you never do it with love. We are always shouting, sometimes even pinching or slapping. It's very rare that we see people correcting with love. The compassion, the empathy is lacking. So all of his mother's contributions were acknowledged by Mendeleev. And he wrote down this in his investigations. And when he arranged the elements in an amazing table that is called as the Mendeleev's periodic table. And now let's look about it. The periodic table proved to be the unifying new principle in chemistry. It was a motivation for the discovery of some new elements because from when Döbereiner started his amazing quest to put the elements in amazing classification and periodicity, but they were not quite so successful. And somewhere in the line, when you're not successful, you're doing a lot of attempts. Now, for example, if you're trying to make a gold chapati, yes, and you're like, I have to get it right, but you're not getting that perfect circle. What do you think? You get demotivated, right? But your mom, your dad, your brother, your siblings are there with you, and they're like, you can do it. Yes. And you get that motivation to draw a perfect circle, to make a perfect gold roti, or to do anything, right? So Mendeleev's success was that dose of motivation for all the people in the community to get back again, to get back up again and discover some new elements, work on the classification and get it correct. Yes. Now, why was this such a great motivation in the history of chemistry? Let's find out. So during the time of Mendeleev, when he was like, I am going to classify it, 63 elements were known. Okay. Now, till now, what did we see? We saw that Newland and Döbereiner were trying to classify, but they were just on the superficial level. They were going and increasing atomic mass number. Yeah, they were. But over here, what we find different is Mendeleev studied the relationship between all the elements with regards to their atomic mass. That's correct. He studied the relationship between them. Yep, right. And the another important thing is he studied the physical and chemical properties. No one ever did so till now. But Mendeleev came up with this amazing idea and he went for it. Among the chemical properties, Mendeleev concentrated on compounds formed by these elements with hydrogen and oxygen. Now, why do you think he concentrated on hydrogen and oxygen? I'll give you 10 seconds to think. Think about it. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay. So he's studied the formation of compounds with hydrogen and oxygen because they are very, very reactive. That is correct. So what did he do? Have you ever played that game of solitaire on the mobile PCs where you arrange the cards as king, queen, jack, then 10, 9, 8, 7, 8, 10, 9, 8, 7, 6, 5, 4, 3, 2, ace? Yes, right? So what did Mendeleev do? He did not take a book. He did not go on every page and wrote, oh, aaj hum karenge hydrogen. Today we are going to do research on hydrogen. Did he do that? No. He did not go to a book. He took 63 cards. Something like flashcards. He took a card. He wrote down the name of the element. Yes. then wrote down the properties of that element one by one. Mhm. As he was doing his research. And when he finished with it, he looked at the cards on his table. Yes, he analyzed each one of them and then he sorted them out on the basis of their similarities. And then he pinned them on the wall where he can have everything visible to him at a glance. That is correct. Because today, when you look at the periodic table, do you have to search for S block in one page, D for another, F for another? No, everything is available to you at just one glance. That is correct. So the most of the elements got a place in the periodic table and were arranged in the order of their increasing atomic masses. The same pattern that was used by Döbereiner and Newland, and that is always remember increasing order of atomic masses. Okay, utterly important line. Now, have you ever wondered? Now, have you ever wondered why? Why do we write the name of our periodic table as the periodic classification of elements? Why is the word periodic there? Because when you look at the periodic table, yes, and you're like, these are the elements, what do you do about them? Hmm? So you will notice that there are some properties, physical and chemical, which are repeating after some interval. That's right. And that too, they're recurring again and again in the periodic table. What does this mean? So, this property of recurrence of the properties of elements, which are similar, both physical and chemical, is called as periodicity. It is called as periodicity, and this is why we have the term the periodic classification of elements. The modern periodic table, everything has the word periodic. Why? Because recurrence of physical and chemical properties of the elements in it. So Mendeleev formulated a periodic law which states, yes, what is a periodic law? Which governs the periodic table. On this basic law, we have the whole table laid out. Yes, and the law is the properties of elements are a periodic function of their atomic masses. Mhm. So all of those periodic functions and everything that I gathered, because how did Mendeleev classify these elements? He classified them on the basis of their atomic masses, right? Yes. And these atomic masses, my dear children, are the periodic function of the properties of elements in the periodic table. In the Mendeleev's periodic table. So the properties of elements are the periodic function of their atomic masses. This is the periodic law of Mendeleev, and you need to remember it because Mendeleev is a hot topic, and its periodic law is going to be more of hot topic when you write the answers about Mendeleev's periodic table in your board examinations. So do not forget that. This is how the amazing periodic table looked like. So it again had something called as groups and something called as periods. Okay. So this line over here in dark green in Roman numericals 1, 2, 3, 4, 5, 6, 7, 8, dance. I'm not giving you the beats. So he named these vertical columns of 1, 2, 3, 4 in the Roman numericals as groups. Whereas if you see this 1, 2, 3, 4, 5, 6, these were the periods of Mendeleev's periodic table. So anything which goes in the horizontal line is my period. Yes. And anything which is vertical is my group. Okay, this is how he was able to, like, oh, like for example, if you're doing GPS, we have the coordinates, we have the longitude, we have the latitudes of the earth. Similarly, if I want to know, where boron is, and you'll be like, ma'am, on the third group, second period. And when I just do that, voila, I found boron there. Understood? So this is how we have the groups and the periods, and this is how they help us to locate things at ease, very easy, very quick. Oh, from Quick, I remember the game you used to play. Quick, Quick. Did you play that game? Let me know. So there are a few instances where Mendeleev had to place. Now, when everybody does some work, we have some achievements, and then we have some limitations related to it. Right? Now, let's look at some achievements, and obviously, there will come a time for limitations also. So, some of the achievements of Mendeleev's periodic table were, there were a few instances where Mendeleev had to place an element with slightly greater atomic mass before an element with slightly lower atomic mass. And I'll give you the example. For example, we had cobalt. Okay, the atomic mass for cobalt is 58.9. Okay, and nickel is 58.7. So according to the masses, as we are going in increasing order, nickel should be first. Yes, and cobalt should come after nickel because 58.9. But you know what Mendeleev did? Mendeleev placed cobalt before, and then he placed nickel. Why? Because he had some mentors, and he was like, you know what? The properties are going from cobalt to nickel. Yes. But the atomic mass is different. But you know what? I'm going to ignore that. And he did so. And he changed the sequence, and which was absolutely correct when we now know the modern periodic table. His instance, his gut, his amazing research was amazingly at point. The next big achievement, which is just unbelievable, is he left some gaps in the periodic table. That is right. He was like, you know what? I'm going to leave it. Because I think from A to B, okay, if I have this element A already found out, and I have element C which is already found out, and I see कि वहाँ ना बहुत ज़्यादा gap है. There's something missing. And I'm like, you know what? There is going to be something in there in the middle. And you know what I'm going to do? I am just going to leave it blank. I'm going to give a space so when it is discovered, it can be placed over there. That's right. And he gave that word or the prefix of eka to the name of the preceding element in the same group, which was yet to be discovered. So he left 3 such gaps, okay? And they were known as eka boron. Okay. Then another was known as eka aluminium. And the other was eka silicon. You know, they were later discovered. Eka boron, today we know as scandium. Eka aluminium, today we know as gallium. And eka silicon, today we know as germanium. Absolutely correct. So he was such a genius. These were not even found, and he still made space for them in his periodic table. And you know the amazing part? He even predicted their properties. How can? He is not an astrologer, guys. He is just a common man with curious mind, amazing scientist, brain chemist. So what is he doing? So he predicted the properties, guys. Let's see. Eka aluminium is what Mendeleev predicted. Yes, and this is what it was actually found to be. So Mendeleev said, you know what? The atomic mass of eka aluminium sorry, It is going to be 68. Mhm. And when aluminium, that is gallium, was discovered, the mass was found to be 69.7. And I think the difference of 1.7 is not big because it was not even discovered, guys. Formula of oxide, when he was like, you know what, when this element will be discovered and it will be reactive with oxygen, you get an oxide, right? Yeah. And that is going to be E2O3. That means the valency of this component, of this element, which is yet to be discovered, will be 3. Yeah. And you know what? He was right. When gallium was discovered and reacted with oxygen, it was found to be Ga2O3. Absolutely correct. Genius, isn't it? And he was like, you know what, when again, oxygen batao, the chlorine bhi bata hi deta hu. So when this will be reacted with chlorine, you'll get it as ECl3. That is GaCl3. And it was amazingly right, guys. It was right. It was to the point right. Over here, E means the element, which is not yet found. And Ga means gallium. Do you see how right he was with his observations? And that is one of the major achievements of Mendeleev's periodic table. Another big achievement was, we had Newland, right? We remember Newland, yeah. And he was like, 56 elements are known, and I'm not going to get any more elements. They're not going to get discovered. But Mendeleev was like, he was open. He was like, there will be more elements that will be discovered. And when later on, Group 18 of the modern periodic table, that we all know as the noble gases, the elites, which do not mix with anybody because they are already stable. Yeah, all their octets are filled. So when they were discovered, very late after Mendeleev, they were inert. Yeah, all their orbits were filled. They were like, oh, I am it. And they were present in the environment at extremely low concentrations. The noble gases are present out there, but extremely low concentrations. And that is why it is very difficult to first of all discover them. Yes. But when these gases were discovered, and they were like, you know what? I think Mendeleev's periodic table is not going to be so good because now we have noble gases. Where will I place them? And to their surprise, guys, to their surprise, the new group of noble gases could be placed in the modern periodic table without disturbing what we already had, without disturbing the existing order of the Mendeleev's periodic table. Isn't it amazing? I know. So, after achievements, we come to the limitations of Mendeleev's periodic table. Because obviously, the periodic table was amazing, so nice, but there are limitations also. So, the first was hydrogen. Hydrogen was such a confusing element. It was like, hydrogen had the electronic configuration which resembled the alkali metals. Mhm. Hydrogen combined with halogens, oxygen, sulfur to give chemical formulas like how alkali metals give. And you can see the proof here. When hydrogen reacts with chlorine, it gives HCl. When sodium, which is alkali metal, reacts with chlorine, it gives NaCl. When it reacts with oxygen, it gives you H2O. When sodium reacts with oxygen, it gives you Na2O. When it reacts with sulfur, it gives you H2S, hydrogen sulfide. And sodium gives you Na2S. Quite similar, the pattern of engaging in a chemical activity. So it was like, hydrogen was like, I am an alkali metal. But hydrogen existed in the diatomic form, that is as H2. It combined with metals and non-metals to form covalent bonds. And you know what? Whose property is this? This is the property of halogens. So hydrogen over there was trying to be clever. He was like, I'm alkali metal. And then he would snoop around you and he'll be like, I'm halogen. So it was very difficult for Mendeleev at that period of time to give hydrogen a fixed place, a correct place. Yes, so that was the first limitation of Mendeleev's periodic table. The second was isotopes. What do you mean by isotopes, ma'am? That chlorine is found in two forms in the atmosphere. One as chlorine 35 and the other as chlorine 37. But these isotopes was not discovered when Mendeleev was alive. So when isotopes was discovered, the concept of isotopes was named to the human mankind. That was a challenge. That was a challenge for Mendeleev's periodic table because when Mendeleev was alive isotopes were a thing was not known. So Mendeleev had proposed the periodic table before the discovery of isotopes. And hence, people could not understand. यार atomic mass में तुमने डाला है periodic table में 35, 37, but ये तो same है. So what will we do? Chlorine is the same element. They have different atomic masses. What am I going to do? Where am I going to place it in the periodic table? So that was a challenge. That was a challenge for Mendeleev's periodic table, and hence it is a limitation. The atomic mass do not increase in a regular manner from going from one point to the other. No regularity. If it is 2, it should be 3. If it is 2, it should be 4. Yeah, there should be some arithmetic, some thing. If you see the modern periodic table, you will see we have hydrogen 1, then 2, then 3, then 4, then 5. Yeah, just going in straight numbers. But nothing of that sort was. There was no manner. There was no arithmetic progression in which my elements were placed. They were just there. That was another limitation for Mendeleev's periodic table. So these are all the limitations, achievements, and what Mendeleev's periodic table was all about. And let me tell you, Mendeleev's periodic table is a hot topic for your board examinations, along with obviously modern periodic table. So make sure that you know the crux of it. Yeah, do not leave it as it is. कौन पूछेगा Mendeleev का इतना बड़ा हो गया था. No, do not do that. Okay, just remember it. 63 elements were known. Remember the periodic law. That is very important. Then the groups, the periods, the gaps that he left is of utmost important. Yes, because they were not even discovered. Then cobalt and nickel placed before. Yes. Limitations, very essential. Because they can ask this as individual topics. Tell me the limitations, tell me the achievements, rather than being a one whole topic. So you need to be able to answer. Okay, so do this. Now we move on to the modern periodic table, and one thing that we will just discuss in today's session, and will not discuss. Let's see how much we discuss, but it was there into existence because of Henry Moseley in the year of 1913. Yes. And he just changed one thing, guys. He changed one thing, and the whole face of the periodic table was changed. He said that atomic mass, what Döbereiner, Newlands, and Mendeleev did, they considered atomic mass as a fundamental property. And they arranged the elements according to the increasing atomic masses. Nobody ever thought about what Henry did. He thought about atomic number. He said, sorry, he said that the atomic number is the fundamental property while classifying, while making the periodic table, rather than its atomic mass. Absolutely. Yeah, it's absolutely correct because we are following the modern periodic table. So in 1930, Henry Moseley showed that the atomic number of an element is more fundamental property than its atomic mass. Voila. So Mendeleev's periodic table was adopted, but adopted with some amazing differences to be made. And first was the atomic number was adopted at the basis, the foundation of my modern periodic table. The foundation was atomic number. Yes. And the law of modern periodic table is properties of elements are a periodic function of their atomic number. But if you remember Mendeleev's periodic law, Mendeleev's periodic table law, yeah, what does it say? Properties of elements are a periodic function of their atomic mass. Just one word you have to change and you get it there. So you remember one, you are automatically remembering the other one. Yes. So just go hand in hand. Correlate, understand what is going on in the chapter. You don't have to mug it up, you don't have to ratify it. Just understand the crux. How they are just changing teeny tiny bits and it is coming out to be a beautiful picture. Yes. So correlate, understand what is happening, and believe in me, you will get it right. So the modern periodic table was arranged in increasing order of atomic number, and we denote atomic number as Z. And this led us to the classification of modern periodic table, and it helped the prediction to be more precise. Yes, because we were arranging them in increasing atomic number from 1, 2, 3, 4, 5, 6, 7, 8. And if I miss the 7, I know there is a 7 in the middle because I know the number numerals go like this. Yes. So the prediction became very, 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 very easy. So today we are going to discuss only this much. In the next session, we will go into the details of the modern periodic table. Till then, I would like you to study 3 things. Döbereiner triads, remember at least 2 of them. Newlands classification, octaves, and Mendeleev's periodic table. Okay, just chew them, just read them, understand what they must be feeling at that time. Do not ratify it. Okay, understand, make connections, and that will be much more easier, better for you to learn and understand. Okay, so this is it for today's session. I will see you next time. And I hope you enjoyed the session today. So, till the next time, stay at home, enjoy, and I hope you're having a great Diwali. Stay happy, stay blessed, stay home, and take care of yourselves and everybody along with you. Okay, take care, guys.